Hello everyone, Shine is here. I've been asked by a few students regarding the table in your first track, table 2, and it seems there are uncertainty on how to interpret or fill the table. So first of all, this document is self-contained. The instructions either for the first track or the project, just all you have to do is to read it. And well, the terms have been defined here. The members, you see, they have different lengths, and once they have been numbered by the labels, once they have been numbered by the just numbers. This is because when you are using the web calculator, that doesn't accept the letter; it only accepts the number. So that's why this seems to be different in two ways. And when you get into table 2, you don't have to fill in all the data. So I have asked you to just do one scenario. For the scenario which you have been told, for example, this one, all you have to do is you are applying a test load. The test load is 16 Newton, but that 16 Newton, depending on the value of the theta, can be resolved into X and Y components. So you put X and Y components of the 16 Newton here, depending on the angle, which is made by the horizontal line in the positive x-axis. And then the rest of these things, the collapsible member, once you solve the hand calculation or the web calculator, the largest tensile load, that is the most suitable member to be replaced by a collapsible member. So collapsible member is, for example, the member which has a strong magnet in it. For example, if you find out the largest load inside the structure is 1, 2, then the collapsible member will be 1, 2. And here you simply mention 1, 2 in front of here. And then this comes, what is FIC? FIC is the internal load that develops inside the collapsible member due to the application of 16 Newton. But that 16 Newton is not enough to break the member. The chances are you have to increase that load. So in this case, you put the collapsible member under the left hand side of the rig. You place this one right here, and then you measure what load actually breaks the magnet. So once you have that force, this force is larger than what you calculated inside the member. How large that is? So you find the magnification factor K, which is the ratio of what was measured to cause the breakage and what was calculated due to 16 Newton. So for example, if that's 2 or that's 1.2, it means you need to multiply that force by the test load of 16 Newton to make that particular test collapsible member to break. And this is, you calculate, instead of applying 16 Newton, if I apply TC, yes, theoretically your collapsible member should break. That's the meaning of a linear structure. But due to some errors, maybe you need to apply a slightly different tensile load before the things break. So that column tells you what tensile load did you apply to get that magnetic member break, and this column tell you what, according to the calculation, according to the magnification factor, what tension should be applied to get it break. And then comparing these two numbers, the calculated value and the measured value, you can write a conclusion and discussion. And that's all being asked. I hope this video clarifies for you. If you have more questions, feel free to ask me. Take care and